Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Cucuk Nur Rosyidi, and I am one of the invited speakers in the 6th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering, or ICIMECE, which held by the Faculty of Engineering, Universitas 11 Maret on the 20th of October 2020. Today, I will present my talk about a framework of integrated sustainable make or buy decision model. This is the outline of my presentation. I will start with introduction and then followed by literature review and then the proposed framework and will be closed with conclusions. A product undergoes several stages in its life cycle, from product design and development, manufacturing, consumption, and end with disposal. Today, due to the rise of environmental issues, sustainability becomes one of crucial aspects in production. With sustainability, a product will be returned to the manufacturer and will be reused through remanufacturing process. In this slide, I will focus with general product design and development methodology taken from the book written by Ulrich and Eppinger. As we can see in this slide, the product design and development consists 6 phases. Start with planning in phase 0 and then followed by concept development, system level design, detail design, testing and refinement, and will be closed by production ramp up in the last phase. From those 6 phases, we will more focus on the detail design phase. In the detail design phase, a designer should determine a set of certain quality characteristics in the form of dimensional and performance-based characteristics. A subset of those characteristics will be assigned as the product's key characteristic, which must be controlled during the manufacturing process. Then it is important to develop a framework to integrate the decision process in product design stage and manufacturing stage in order to increase the decision-making process and the use of time and other resources. In the detail design, a designer has to determine the geometry of component and tolerance assignment. Tolerance has been known widely as the connector or bridge between engineering design stage and manufacturing stage. In engineering design stage, the tolerance assignment will have some consequences to the product, such as performance or quality, sensitivity, robustness, and customer satisfaction. While in production or manufacturing stage, it will affect manufacturing costs, assemblability, process capability requirements, the requirements of operator skills, and the number of scrap and rework. With such consequences, the tolerance must be set tighter in design engineering stage, while looser in manufacturing stage. Thus, the tolerance has to be set by considering both stages simultaneously. There are many research discussed about optimization model development to determine the optimal tolerance. Generally, there are 2 approaches in tolerance modeling. The first is continuous model approach, and the second is discrete model approach. In continuous tolerance model approach, the tolerance is treated as direct decision variable, while in discrete tolerance model, the optimal tolerance is found through process selection, such as the model developed by Chase et al. In 1990, or supplier selection, such as the research developed by Feng et al. In 2001. Those research assumed that the manufacturer fulfilled all the needed components exclusively in-house or outsourced to the suppliers. These assumptions can be relaxed by making the manufacturer fulfill the needed components in both ways. The decision concerning this issue needs make or buy decision making. Several research have been conducted in integrated decision of engineering design stage and manufacturing stage through make or buy decision making. Make or buy decision making mainly consists of two decisions: process or supplier selection and order allocation to the each selected machine and or supplier. There are also some considerations in the decision makings, such as quality improvement activities consist of prevention, appraisal, and failure, simple sequencing and delivery lateness, make-to-order system, learning and forgetting considerations, offline learning, sustainability considerations, consists of remanufacturing, the inclusion of carbon emission, and how to use the energy efficiently. This slide shows a simple proposed framework which also can be found in many works dealt with sustainability issues, where beside forward production, there is also reverse production, deals with the returning product through collectors who will disassembly, sorting the components and bring back the components to the manufacturer to be reused. We found an interesting model developed by Wang et al. In 2016, which can be integrated with the existing model of make or buy decision making. In their research, Wang et al. Developed or used bus model to determine the number of return product in one product generation and extended their works in 2017 with multi-generation. The general pre-processing operations in Wang's model include disassembly, cleaning, refurbishing, and testing for quality control. They also consider one component in the collected end of the product and then focus on the collection and reprocessing operations, and also calculated the cost saving, which comes from the difference between manufacturing new items and remanufacturing items, which consists of three costs. The first is cost comes from manufacturing or purchasing the new items and also included penalty costs. The second cost comes from reusable items, which include acquisition, reverse logistics, and reprocessing costs. And the last is cost comes from non-reusable components, which the components of cost same as reusable costs plus disposal costs. These costs are then used to calculate the cost saving comes from difference between cost manufacturing of new items and remanufacturing items. Wang et al. Used the bus model to determine the number of return product. The bus model is widely used to dynamically predict new product sales in the market and is reported to work exceptionally well by many research. The basic bus model considers new product diffusion to both external and internal influences on customers, and the equation is shown in the slide. Based on the bus model, and then the quantity of product sales can be expressed as the equation as we can see in the slide. And so for the number of adopted or product sales and time t, we can find how many products will be returned to manufacturer, as we can see in the second equation in the slide. And this is the differences between Wang et al. Model in 2016 and Wang et al. In 2017. In their research in 2016, Wang et al. Consider one product generation, while in their later research, they consider multiple product generations. The difference between those two research is that in the later research, they extend their research in 2016 by considering multiple generation. It means that the product produces by more than one generation. We identify some problems in integrating the Wang's model to our model, and since this research is still under development, we need to identify some problems. The first, in Wang's model, there is a lead time consists of useful lifetime and time to collect and processing the return product. And the second problem that we have to determine the remanufacturing cost function, which must be expressed in relation with tolerance assignment. And we conclude this talk. First, we reviewed the literature on integrated sustainable make or buy decision, specifically the ones that make simultaneous decisions on product design and process and supplier selection, along with its order allocation. Second, we described the opportunity to include the bus model in make or buy decision problems to allow sustainability consideration based on Wang et al. Model. And the last conclusion, we identify some problems in model development. First, how to account the lead time comes from useful life and time to collect the return product, and also the representation or expression of remanufacturing cost function in its relation with tolerance assignment. That's all my presentation. Thank you for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.